Hello everyone, welcome to the Canada Truth Channel, where Canada, the illusion of freedom and system of control is exposed. Today's video is a little bit different. I have constructed a Tesla turbine out of an old 24 volt DC motor. I gutted the motor. I cut off all the copper windings, and I was left with a stack of these laminates. So I then decided I would cut out the centers of these laminates because they were pretty much half of the size of a CD, half of the width of a CD, which I intended to use for my blades. Now, I cut them out using a Dremel, and I came up with basically a very rough cut, like so. I flattened them out. I then crafted a way to machine them down to size, and I put them all on this 3/8 bolt. I put a washer and another nylock nut on the top, like so, and using a file, spinning the drill, I machined them down to size, which then I wound up with something like this. So I started off with a CD. The housing I had is an irregular size, so I didn't really have a good way to cut the CDs down to size. I started off with big heavy scissors, which wasn't a very efficient way. It was hard on the hands. I wound up with a pretty rough cut. Took a long time. So I decided there must be a better way. Using what I had in my garage, I came up with, okay, well, I'm going to make my own lathe. So I sanded the discs down using a palm sander, and when you sand them down, they basically look like that. I mounted 6 at a time in my grinder. I put the grinder, I laid down a rubber mat on top of my bench to try and reduce the vibration as much as possible. I used the guard as a guide, and I used a file, I used a knife, and I also used various different grits of sandpaper, and believe it or not, I was able to come up with a pretty good disc. I then epoxied my machined spacer slash mounting washers, and then I drilled the holes. I didn't have a drill press or anything, and I found drilling stacks of CDs at a time. I was breaking a lot of CDs. And this one here, if you have a look, you can see a crack where I was drilling the holes. So out of the whole process, drilling the holes in those CDs was the most difficult part. They're not equal, they're not symmetrical around the disc. And in fact, because I had to drill them only a couple at a time, the holes aren't perfectly aligned. And not only that, the holes aren't aligned inside the turbine. So these holes are the exhaust ports, and unfortunately, just because I'm using limited materials on basically what I have, the holes aren't lined up, and I didn't expect a very good result. Not only that, I broke a whole bunch of CDs in this manufacturing process. Once I got the CD down to this size, got the holes drilled and the spacer mounted, I then mounted them on the shaft. So I mounted them on the shaft, and then I took that shaft and put it in my drill. Once again, the drill's on rubber mat just to try and reduce the vibration a little bit, but I used the same process as I used with the grinder to get them down to size, but I actually mounted them on the rotor and then did my best to balance them on the rotor using this drill and this technique. Once again, very delicate procedure. This is very primitive manufacturing, but the results are absolutely amazing as far as I'm concerned. So I broke a bunch of discs. I ran out of discs, and I thought, you know what? Before I go waste a bunch of time and start all over making new discs, I'm just going to put this together and see what happens. So right now, I didn't even bother to count the discs, actually. I have discs from about this red line to this edge right here. This is wasted space, and all of this here is all wasted space. So yeah, my discs only go from about here to about here, and I have wasted space on each side. Not only that, during the manufacturing process, using the grinder and the drill, some of the discs heated up, some of them warped a little bit, so it's hard to see, but they're not as they should be. So the spaces between the discs aren't all equal. The spaces between the discs are not centrifugal to the disc. So there's a lot of issues. I really didn't expect much, but I thought, okay, I'm just going to try, see what happens, to see if I stop what I'm doing and pursue different material right away, or try this out. So I will show you the results directly. Okay, so I only have a small 5-gallon air compressor, and I don't have a water trap on it, and it runs out of air pretty quickly. So I'm starting off with 100 psi, and as I'm applying the air pressure to the turbine, of course, the tank pressure is going down, therefore the line pressure is going down. And pretty quickly, it gets down to about 60 psi, and I'll show you what happens. So here we go. As you can see, it works pretty well despite this very, very rough manufacturing and limited air pressure. So the air pressure keeps going down. Right now we're at about 60 psi. Of course it's slowing down as the air pressure decreases, but it gives you a pretty good idea on how efficient these things are. This one in particular, despite all the issues, despite all the deficiencies, and despite the very, very primitive manufacturing techniques, as you can see how long it continues to spin using my DeWalt lathe, I was able to get those discs on that shaft pretty well balanced. Right now, I am down to about 30 psi on my tank. Line pressure. And you can see it doesn't take a whole lot. So there's many doubters out there that say Tesla turbines don't have any torque. This has a surprising amount of torque, once again, despite all the deficiencies. And I think it's going to easily be able to drive the next portion of this experiment. So I think it's gonna work. This is all proof of concept build, so it's down, dirty, and cheap. Now I'm gonna look at better discs, better manufacturing, make sure all the exhaust ports are lined up inside the turbine so it exhausts properly. Make sure there's no wasted space. Make sure it's sealed up properly. Another issue with this little compressor of mine, there's no water trap on it, so it's actually spitting quite a bit of water into this little turbine as it's spinning. I don't have a digital tach, so I don't have any real estimate on how fast it got spinning, but as you could hear, it was howling pretty good there. And I wasn't holding it on the bench. This is just a rubber mat, and the vibration, even with this rough manufacturing, was little enough that it didn't actually vibrate and move. And you saw how long the shaft spun after I took off the air. So I was quite amazed at my DeWalt lathe, what a good job it did actually balancing the blades on the shaft. So I will hopefully this weekend get access to a bigger air compressor with a water trap on it, and also a digital tach, so I can have a good idea at how fast this sucker can spin as is. I don't think I'm going to mess with this one anymore. It's been taken apart and put together and tinkered with a whole bunch of times, and the discs are pretty fragile in there. So I think I'm just going to leave this and start my initial testing with this while I'm thinking about finding better material for the discs. So if you're interested, please stay tuned. Anyone can build this same Tesla turbine in their garage. This isn't even following Tesla's specs from his patent. This is just using the idea. It's incredible on how well this thing works. So stay tuned. Hopefully sooner than later, I'll be able to show you the next phase of this experiment and put this little fella to use. So despite all the little issues I have with this thing, it's performing way better than I expected. And the next iteration with proper blades in there, I expect to be more than adequate for what I need. So stay tuned for the next one. Like, share, and subscribe to the channel. Thanks for watching. Bye.